Let's take a look at this question together. Question says that we have an intensity of a certain sound wave is 6 microwatts per centimeter squared. If the intensity is raised by 20 decibels, the new intensity is what? Well, it's a little bit of a problem. We're raising it by 20 decibels. I'm not comparing it to a background. But I know that the decibel reading is given by 10 log of intensity over intensity naught. Intensity naught is the threshold of hearing. This is what we measure decibel reading. But I don't want beta. I want the change of beta. So I'm going to do beta 2 minus beta 1, which is going to be 10 log of I2 over I naught minus 10 log of I1 over I naught. If I rearrange this equation and I can work through some math, I'm going to get 10 log, and I'll see that these two logs, this one and this one, when I subtract them, it's dividing their arguments inside. So what I'll get is actually I2 over I1. And this will be my change of decibels, so beta 2 minus beta 1. So now when I actually plug in my values, I'm going to actually work this out, do a little rearranging so I can solve for I2, because I2 is going to be my final, I1 is my initial. So I'm going to raise my initial to get I2. So this is going to be delta beta over 10 is equal to log of I2 over I1, or delta beta over 10 raised to this, times I1 is going to be I2. So a little involved, but nothing too terribly difficult. So let's go through and plug in the numbers. So I have 6 microwatts per centimeter squared times 10 to the delta beta. Well, delta beta is 20 decibels. 20 decibels over 10. And this is going to be I2, which is the same as 6 microwatts per centimeter squared times, well, 10 to the 20 over 10 is 10 to the 2, which is just raising by a factor of 100. So when I look at my answer is 100 times my original. So if it's 6 microwatts and I want my new answer in microwatts per centimeter squared, then it's going to be 600. So a 20 decibel reading increases the actual intensity, the actual power that's hitting a certain area, by 100 times.